Okay, well, our efforts to flip the classroom ran into some issues on Monday night and Tuesday night because YouTube is not the best way for us to do these videos. But in the process, we found out, I think, a better way to do the videos, only time will tell, is that I will upload them straight to Google, the Google Drive. And actually, this could work out well because you should just be able to download it right to your computer, and nobody should have a problem with not having the internet at home. So Monday and Tuesday, we'll just do the video in class, and I'll give you the paper homework instead. So it's a process. So this hopefully will be our real, truly first flipped class video for homework. And this video is introducing the topic for Thursday, which is adding and subtracting fractions and mixed numbers. So this would be your homework for 25th of September. 25th of September, and we're going to be talking about fractions and mixed numbers. And that's a shortcut for numbers. And we're going to be adding and subtracting only today or Thursday and Friday. And the adding and subtracting are actually, well, multiplying is the easiest. Adding and subtracting presents some difficulties with finding a common denominator and setting up the problems correctly. There's also multiplication involved because when you're finding a common denominator, you have to know your multiplication tables pretty well. So what I thought I would do today on this video is just show you the method or the algorithm or the way we do it that I'm used to seeing. Now, I know some of you will have some different ways to do these, and you'll be able to discuss that when you discuss your whisk in class, assuming everyone can watch the video. We'll play it by ear. Sorry, the book knocked into the iPad. All right, so let's just take an easy problem to start with. Let's just do 1/2 plus 1/3. 1/2 plus 1/3. Now, that problem is set up horizontally, and whenever I'm adding or subtracting, I like to immediately turn it into a vertical or an up and down problem. 1/2 plus 1/3. So 1/2 plus 1/3. And then I like to set it up this way so I can make sure I have my common denominator, because when you're adding or subtracting, you must have a common denominator or a common picture of how it's set up, representation model, which hopefully we'll get to see when we look at the Carnegie book tomorrow for tomorrow's video. But I'm just going to show you the nuts and bolts today because this should be review for a lot of you. So if you think through your multiplication tables, we need the least common multiple. And if you need to list them out, the multiples of 2 are 2, 4, 6, 8, keep going, and 3, 6, 9, 12. And you find the lowest one, so we don't have to do any extra work, and it happens to be 6. So we're going to do 2 times what equals 6? And hopefully most of you know that's 3. And whatever I do on the bottom, I also have to do on the top. So 1 times 3 is 3. 3 times 2 is 6. So 1 times 2 is 2. Then I have to add the numerators, which is the number on top. And 3 plus 2 is 5. And the denominator stays the same. So we're going to end up having 5/6 as an answer. Now, it looks a little complicated because I'm writing out every thought process that I have. And I even still do it this way, even if I wasn't a math teacher. And even though I am an older person who has been doing math for a while, I still write it out that way because it really keeps me from making mistakes. Let's try a slightly more difficult one out of the textbook. Let's do 6/7 plus 6/9. 6/7 plus 6/9. And the textbook always writes it like this, even though it's really not the best way to work with fractions. So I immediately take it and I write it vertically. 6/7 plus 6/9. And then I set up my equal signs. And this is going to come into play the way I'm doing this later when we start talking about ratio and proportions, because I'm actually building equivalent fractions, which have a lot to do with ratios later and proportion. So I got to think about my multiplication tables. 7 14, 21, 28, 35, you know, and you keep going. I'm hoping that you guys know these. 9, 18, 27, all right? And you keep going, and you keep going. And then hopefully you will find out that way down the road somewhere, 63 is really the lowest common denominator that we can use, which happens to be 7 times 9. So 63. So we're going to do 7 times 9 is 63. So I also have to do 6 times 9, which is 54. And if you'll remember from the video we're going to watch earlier in the week, that's just a 1. That's all I've done. So I'm not really changing the value. I'm just using 1 to create an equivalent fraction. So 9 times 7 is 63. 6 times 7 is 42. And then, it takes the whole thing away. Yikes. Let's see if it'll give me back. Okay. So let me get rid of this so I can write something in here. All right, I need the pen back. So now I'm going to do, because I'm adding 54 plus 42. 54 plus 42. 54 plus 42 is 96. And then I keep my denominator. So 96 63rds. 96 63rds. And I'm sure some of you are looking at that and seeing 3's and ways that I can reduce this by 3, you know, to make a simplified fraction. I'm not going to worry about that right now because I don't know if you guys remember learning the grid last year for gridded response questions, but you would actually want to keep this possibly in this form. So we'll talk about simplifying on an easier fraction to simplify. All right, let's try one more addition problem. 9/10 plus 1/3. Let's try 9/10 plus 1/3. 9/10 plus 1/3, and of course it's written this way, so I'm immediately going to write it vertically. I'm going to set it up to make my equivalent fractions, and I'm going to find my common denominator. And really, if you list out all the multiples, you start to get a sense for it, but most of you should probably realize that 30 is your least common multiple. Now, as long as you have a common multiple, you're okay. The least just makes it easier, but if you're lost and you just don't know what else to do, just multiply these two together and work from there. So 3 times 10 is 30, and 1 times 10 is 10. So that's how I'm getting 10/30ths, which if you look is equivalent to 1/3. Most of you can get that. 10 times 3 is 30. 9 times 3 is 27. I'm adding. It's always good to check. 27 plus 10 is 47, and I keep my denominator. It's kind of like a last name. They stay together. Now this one is an improper fraction. Again, with the gridded response, that crazy grid thing that we have to do on our standardized tests where you have to put an answer in and then bubble it, you would actually want to do 47 divided by 30. I mean, you could simplify it, but you can't, mixed numbers you can't put in. You cannot put in a mixed number. So if you want to simplify this, 30 goes into 47 one time with 17 left over, and the denominator stays the same. And 17 is a prime number, so I really can't do anything else with that. But you cannot grid this number, or it looks like 117 divided by 30, which is wrong. And we'll talk about gridding more as we go on. All right, subtracting fractions. 3/4 minus 1/6. Everything else is the same until we get to the final step, which is the subtraction. Now, if I listed out all the multiples, hopefully you guys would catch that 12 is better than 24. 24 would be okay. 6 times 4 is 24, and it would be okay. You're just going to have to reduce more at the end. So we're going to go with 12. 6 times 2 is 12. 1 times 2 is 2. 4 times 3 is 12. 3 times 3 is 9. But now check, because we're subtracting. Don't fall in that hole. I remember falling in that hole when I was a kid. So we're going to do 9 minus 2 is 7. and the denominator stays the same. 9 minus 2 is 7, and the denominator stays the same. Let's try one more subtraction problem. 2/3 minus 1/8. 2/3 minus 1/8. Again, this is written horizontally, so I immediately write it vertically so I can see everything easier. In this case, the best common denominator probably is 24, which is just multiply them together. 8 times 3 equals 24. 1 times 3 equals 3. 3 times 8 equals 24, and 2 times 8 equals 16. And then I got to look over here and make sure I know what operation I'm doing. I'm subtracting. So 16 minus 3 is 13, and then I keep the denominator, so 13 24ths. And 13 is a prime number, so I know that I cannot do anything else with that. Now, as far as mixed numbers are concerned, it's just kind of adding another layer. So let's try mixed number. 2 1/3 plus 1 1/3. 2 1/3 plus 1 1/3. All right, so I'm just going to kind of do this. And I already have a common denominator, so 1 plus 1 is 2, and I keep the denominator. I think I might have said denominator before, but yeah, that's what I meant to say. Sorry, I'm getting tired. And 2 plus 1 is 3, and that would be your final answer. So you kind of treat the whole numbers and the fractions separately until you get to the very end. Let's try one that has not common denominators. 2 2/3, 2 2/3 plus 4 1/9. All right, so again, this is written horizontally. I'm going to rewrite it vertically. And I'm going to get a common denominator of 9 is probably my best bet. Okay, 9 times 1 is 9. 1 times 1 is 1. 3 times 3 is 9. 2 times 3 is 6. I check, I'm adding. 6 plus 1 is 7, and I get the 9s, 7/9. And then I come back and work with my whole numbers. 2 plus 4 is 6. So 6 7/9. That looks weird. 6 7/9. And again, on the grid, you can't really put it on the grid that way, or it ends up looking like 67/9, which is not the same thing. So we'll talk about that more later. And let's look at subtracting a mixed number, and I'm probably going to get a knock on my door in the next couple minutes, so forgive me if I shut off. I have 5 1/2 minus 3 1/4. Oops. 3 1/4. All right, again, this is horizontally, so I'm going to write it vertically. 5 1/2 minus 3 1/4. Then I'm going to set up my... I lost the little thing that tells me where I'm writing, so this is going to get messy. 4 is the best one, so I'm going to do 4 and 4. 4 times 1 is 4. 1 times 1 is 1. 2 times 2 is 4. 1 times 2 is 2. I'm sorry this is all offline because I can't really tell where I'm writing. 2 plus 1 is 3. Oh, we're subtracting. 2 minus 1 is, see, I almost fell in that pit, 1. And I keep my denominator, which is 4. And then oh, it's back now. Then I deal with my whole numbers and I get 8 1/4. Again, you cannot put that in a grid because it's 81/4, which is not the same answer. So you got to get rid of that. All right, the end of this was a little bit funky, a little bit fast. I'm trying to keep them kind of short, and then my thing started not working. It's really not working now. So I'm going to end here, and please write down any questions on your WISC, and we will clarify any misunderstandings in class. Thank you very much. Goodbye.